Hey guys, so we are back with today's daily lead code. Maximum number of fish in a grid. You are given a zero index 2D matrix grid of size m into n. So int m is equals to grid dot size int n is equals to grid of zero dot size. Cool. Where r actually represent the land cell if grid of r is equals to zero. Okay, land if r is equals to zero, and if it's greater than zero, then water and number of fishes is given by RC. Fishes can start at any water cell RNC and can do the following operations: catch all fish in the sea, move to any adjacent water cell. Okay. Return the maximum number of fish that fishers can catch if he chooses his starting cell optimally, or zero if no water cell exists. Okay. Adjacent cells are up, down, left, right. Okay. I think I get this question very uh, intuitively, like on the first glance, but let's see an example. So 0210. So what is the answer? 7. The fishers can start at cell 1, comma 3, 3, and then they can collect these two. Yeah. So basically, it's a flood fill and DFS. So we come here, we make a visited array of the same size. We come here, we find that this has been visited, this has not been visited, so and it is greater than zero. So in that case, we do a flood pair here, and then we move on to this. We come here, we calculate this, and we move on. We come here, we calculate this, and we move on. We come here and we calculate this, and we move on, and then we get our answer. So that is a basic flood fill, and I think a very basic question. LC medium. Mediums are easy now for me. So let's do this. Uh, how would we start? So vector in. So let's do this. First things first. Let's make n comma n, command D, remove this. Vector int of vector. We have a visitor array. This is equals to this. Uh, what is the size? M comma vector int uh, n comma all of them. So we just need bool. So vector bool and 0. Cool. So we'll know if it's visited or not. Now for int I is equals to 0, I smaller than m, I plus plus. For int j is equals to 0, j smaller than n, j plus plus. Cool. If not this of I comma j and an grid of I comma j greater than 0. Okay. I'm back. Yo. Ah, okay, so if grade of I j is equals to 0, then DFS of I comma j. So grade answer equals to max uh, of DFS of I comma j comma answer. Okay, so I'll have int answer is equals to 0 and return answer. Now let's do a DFS. So int DFS uh int I comma int j if I smaller than 0 or j smaller than 0 or I greater than equals to n or j greater than equals to n. In that case, return 0. Okay. I also, if also or if grid of I j, okay, so grid of I j equals to 0, then also return 0. That's also a case. Okay, so if all these edge cases are done, else return DFS of I minus 1 comma j plus DFS of I plus 1 comma j plus DFS of I comma j minus 1 plus DFS of I comma j minus 1, and also we'll add this number. So gray of I j plus just all its neighboring elements, and if any one of them becomes 0, you return 0. So it comes to 2, it checks all these 4. This will return 0, this will return 0, this will return 1. Now it comes to this. This will go back. So or risk of I j risk of I j equals to 1, and also grid. Okay, so and also this dot grid is equals to grid s1. So int this is done, this works. Let's see, and we get a wrong answer. Hmm. So this will return us. And 19. We should get the correct output. Why aren't we getting? We come to 9 and we'll go into DFS function because greater than 0. Yep. And this this of 9 will be 9 plus. Why doesn't this work? Let's try to debug this. This is very weird. I don't think I need debugging in. Let's see. Ah, mm, mm, I am in. Okay, I get this. Check this one. Uh, just a small plus minus makes things bad. Memory wise, I'm very good. No, no, I don't know. I'm not very good on both memory and uh yeah, not very good. But let's see if we can optimize this. So now, right now, the time complexity is n square, and I can't make a 2D grid lesser than n square. But that constant factor is a lot. The constant factor is a lot because it'll be 2n square basically. And also, I'm making a visitor. So instead of making a visitor, can I just change everything to 0? So mm, mm, so close. I can reduce this constant converter. Switch to 0. And to move this, I can lower the use of visitor, which will help me. Which on if it will it should reduce space by a lot. So yeah, space and time both have gotten better. So one thing's that what can I do more to get an absolute perfect answer? 5167. 5167. Ah, 66, 67. I know one thing I can do. I can make these checks here only. So that will reduce my complexity. But it's just an inelegant way to write the code. Like I know like it will reduce by 1 2 milliseconds. Yeah, I do also understand that it will be a very inelegant way. If I do these checks like before calling these functions, there will be less call stacks and then there will be. Okay, let's do this now. Yes. I want to try it out. I calling for is valid. Does that make sense? Inside every function. That does make the constant factor more only, but I think this is okay. 66, 67. Let's look at the editorial. Let's see if there is a DFS, DFS. Union find, union find, union find. How do they do union find? Time complexity is more, space complexity is same. How to do union find, and find parent, and both roots are not equal. Make one. Okay, it's union by size. Oh, interesting. So, what? Mm, I would like to know union find. Row count, combo count, total sales. Okay, paint, total sales, component size, total sales, total, total fish, total sales. Okay, then all of them are zero. Cell index, total fish of cell index is equals to rid of row column. Okay, got it. We check all the actions. Okay, and we do add a union to a union, and if in the union we do check if they don't have the same root, then we connect these components. So that is how they do union find. Makes sense. I guess this is it.